Good morning, all. I am Mrs. Padmashri from SNS College of Engineering. Today, I am going to discuss about the concept stochastic gradient descent in deep learning. Before we understand about stochastic gradient descent, let me explain about what is a gradient descent in machine learning. So, gradient descent is an iterative optimization process. The main objective of this gradient descent is to find out the optimum value, whether it can be a maximum or minimal value. It is one of the most useful method for modeling the parameter in order to reduce the cost function in machine learning projects. So this gradient descent is very important concept in machine learning. This method is mainly used to identify the model parameter that provides the maximum accuracy in both the training dataset and the testing dataset. Next, uh, in the continuation of the gradient descent, it is a vector pointing in the direction of the function steepest rise at a particular point. This is the exact definition. This algorithm then gradually drops down towards a lower value and then moving in opposite direction of the gradient until it reaches to the minimal value of the function. There are different types of gradient descent. First, we have a batch gradient descent. Second, stochastic gradient descent. Third, mini batch gradient descent. Let me explain what is a stochastic gradient descent. Stochastic gradient descent is an algorithm that's mainly used for optimizing machine learning models. To get the optimized value, we are going to use the stochastic gradient descent. It mainly focused on inefficiency of traditional gradient descent methods dealing with large data sets in machine learning projects. So, SCD, stochastic gradient descent, instead of using entire data set as a single stretch or entire data set is used for each iteration, only a single random training example, or we are considering it as a small batch of data set is selected to calculate the gradient, and we are going to update the model parameter. So instead of considering a big data set or a very large or entire data set, you're going to consider only a small portion of the data set. So this random selection, which introduces randomness in the optimization process, hence it has got the name called stochastic gradient descent. It has an algorithm, stochastic gradient descent algorithm. It has some few steps: initialization, set parameter, and stochastic gradient descent loop. Initialization randomly initialize the parameter values for the model. Determine second, set the parameter value. Determine the number of iterations that we are going to use it in the program and learning rate for updating the parameter. Third is the stochastic gradient descent loop. Repeat the step continuously until the model coverages or reaches the maximum number of iterations. So in this, we have to shuffle the training data set in order to introduce the randomness. Or instead of considering a large data set, only a small training example or a small batch is considered in the shuffled order. Compute the gradient descent of the cost function of the model parameter. These are some of the steps involved in the algorithm. Finally update the model parameter by taking a step in the direction of negative gradient. Because initially it will focus increases towards one direction, then again it decreases towards the another direction, that is the opposite direction, right? So finally evaluate the convergence criteria such as the difference in cost between the iterations. So the last is to return the optimized parameter. After we perform all these iteration value, once the convergent criteria are met or the maximum number of iteration is reached, return to the optimized parameter values. So these are all the steps involved in stochastic gradient descent algorithm. And also one more point added to this algorithm is only one sample from the data set is chosen at random for each iteration. So the path taken by the algorithm to reach. So here is a picture represents a path which is starting from one orbit and reaches towards the um, center, right? It explains the path taken by the algorithm to reach the minima is usually noisier than your typical gradient descent algorithm. So we can just see here the path taken by batch gradient descent is shown below. How it is taken the path from the outer layer and it reaches towards the inner. So a path taken by stochastic gradient looks, see you can see here, it is like not like a previous diagram, it is a zigzag path and it reaches to the inner layer. Okay, so one thing that we have to understand is the SGD is noisier than the gradient descent because it usually look higher number of iterations are needed to find out the randomness or to find out the maximal values in the algorithm. So because of the randomness, we have higher number of iterations is needed. It requires, even though it requires more number of iterations to reach us to the minimal value, it is still computationally much less expensive compared to the gradient descent. Okay? So SGD is preferred over other gradient descent over the batch gradient descent for optimizing learning algorithm. The cycle of taking the values and adjusting based on the different parameter in order to reduce the loss function. The main objective of all this gradient descent algorithm is to avoid the loss function and select the randomness value and also provide the minimal values in the training set. Okay, so this concept avoiding the loss functions is we have already discussed is called a back propagation. So the advantages of stochastic gradient descent is speed, very speed, memory efficiency, avoidance of local minima. Considered as an advantage, and there are, if there is an advantage, then there will be a disadvantages too. There's noisy updates because of randomness in the network, as I already said, because we are going to select the values of maximum to minimum values like randomly. So the path we have seen in the diagram is a zigzag, so it takes more time to reach us to the particular layer. So it is noisy updates, slow convergence, sensitivity to learning rate, less accurate. These are the advantages and disadvantages of stochastic gradient test. Thank you.